All right, good morning. At least for me, it's morning. All right, welcome to Math with Siddig. I had a request to do long division. So there's a couple of things to say about long division of polynomials. The first is there's a couple of different ways that this occurs. You have long division of polynomials with no remainder. You can have long division of polynomials with a remainder. You could have long division where instead of having something that's larger than a trinomial by a binomial, there's a shorter process if the bottom's a monomial, which I'm not going to do right now. This is not the best method in the universe, all right? So you could synthetically divide. This problem would synthetically divide. You could also use tabular method if you liked tabular method. But I just wanted to do a pretty basic example of long division of polynomials with no remainder. If you are in Eureka Math, we'll get to when they have a remainder. If you are not in Eureka Math, then you can get remainder kind of any time. But I guess I just want to say that this is not the be-all, end-all. All right, this is just information about how you long divide polynomials, and in this case, we're not going to have a remainder. All right, I can do a video where we have a remainder. I'll do a video on synthetic division if that's what people want to see, or if I just have the time. I can also do one where it's divided by a monomial. All right, so there's lots of different ways you can handle this. This is just very specific to long division with no remainder. All right, so what you have to remember is that this top part is your dividend, and this bottom part is your divisor. And when you divide, the divisor always goes outside. Now what you also have to double check is the powers. This is 3x to the first, and then this has no x, so I'm not missing any terms. What I mean by that is, if you have a biggest power, you need to have a term for every power below that. So if this had been a squared, I would need to put a placeholder in for the plane x. And I can do a video on that if people want to see it. Okay, but so I'm going to put my divisor outside. I'm going to put my dividend inside. Now notice my dividend is x to the third, then x squared, then x to the first, and then x to the 0 technically. All right, so that's in order and I don't need any placeholders. So I'm going to put my my dividend onto the inside. Okay, now you can do this in your head. You can do it off to the side depending on what makes most sense for you. You can just think about how many times does 3x go into 6x to the third, or if you find that too confusing, you can always just take the very first term. All right, and that's one thing to know about long division is instead of trying to divide this whole thing in at once, I'm going to take just the first part divided by just the first part. So what I'm going to do is I'm going to say, okay, I'm going to take 6x to the third divided by 3x to the first. 6 divided by 3 is 2, and x to the third divided by x to the first is x to the second. Okay? So when you're first dividing, you don't look at the whole thing, you look at just first piece to first piece. And then you have to remember to multiply this back out to everything. So even though I didn't pay attention to the 1, I now have to multiply back to the 1. So 2x squared times negative 1 is negative 2x squared. Because it's an x squared, it lines up in the x squared category, and you want to put a parentheses around it. That's really important because you're going to subtract this entire line, just like in regular long division, and you want to remember to subtract this part. Okay, and then I'm going to multiply 2x squared times 3x, which is 6x to the third. If those two don't match, that means you did your division wrong over here, or you made a bad choice here, and you need to go back and change this. All right, now I'm going to subtract the whole thing. So you have to watch your signs. So 6x to the third minus 6x to the third is 0. That should always be the case in long division. All right, and then 1x squared minus negative 2x squared becomes 1x squared. The two negatives make a positive. So I now have plus 3x squared. And I'm going to drop my next term, just like in regular long division. Okay, so if you haven't long divided in a while, you might be like, but that's just the generic process of long division. All right, now I'm going to do the same thing. I'm going to look at just the first term and just the first term. So I need to take 3x squared divided by 3x to the first. Okay, 3 divided by 3 is 1, and it's going to be a positive 1. So I need to make sure to include my sign. And then x squared divided by x to the first is x. If you forget, when you're dividing, you subtract the powers. Or if you want to think of it as an expansion, you have x squared over x to the first. These two will reduce to 1, so you're left with just x. All right. So back to this. Now I'm going to take that plus 1, and it's got to have an x on it, and I'm going to multiply it back to everything. So even though I ignored the 1 again, I have to multiply back to it. So 1x times negative 1 is negative 1x. Because it's just to the first x, it's going to go in the x column. And then I do 1x times 3x, which is 3x squared. And then I have to remember to subtract everything. Okay, now, so many colors. Oh, you know, let's do the lighter one. 3x squared minus 3x squared goes to 0. Now I have negative 13x minus negative 1. That's going to turn into a plus. Negative 13 plus 1x. If you ever get stuck and you can't do that kind of in your head the way that it is, you can always write it over to the side and think about it that way if it makes more sense horizontally. When they're opposite signs, you subtract. So 13 minus 1 is 12x. And the bigger guy gets to keep his sign. So now I have negative 12x. And then I drop my last term, which is plus 4. One of the reasons I like polynomial division better than actual long division is because once we get here, once we get to that 4 and we can't put 3x into 4, we're done. All right, so right now we're not going to have a remainder, but in the future when we have a remainder, once you hit here, you don't have to do any sort of expansion like you do in regular division. So, all right, now, same idea. I'm going to go ahead and I'm going to do first term and first term. So now I have negative 12x divided by 3x. Negative 12 divided by 3 is negative 4, and the x's will reduce, so all I have here is minus 4, and now I have to multiply that back out. So negative 4 times negative 1 is plus 4, and negative 4 times 3x, good morning, what are you doing, buddy, is negative 12x. Negative 12x minus negative makes plus, that goes to 0, and then 4 minus 4 is 0. And that's how you know you have no remainder, is when you finish subtracting at the end, you get a 0. So when I divide this giant thing here by this smaller piece, this is the answer that I got. If you ever long divide or you ever have a problem and they're like, is this really the answer? You can check it by just doing basic multiplication. All right, so if you want to check your answer, which I know you do, right? Because who doesn't love to check their answer? What you do is you take your divisor times what you got as your answer, and you can do it by distribution, you can do it by, not really FOIL, but kind of like an extra distribution, or you could do box method.
I'll be watching Mama.
Okay, I'm going to do, gentlemen, sorry, both of my children just came into the room and thought that they should talk and also be disruptive. Guys, let me finish the video. All right? Okay, so now I'm going to go ahead and just multiply, and what I just want to make sure is when I multiply that I really did get back to this same initial dividend, and that's how I know for sure that I long divided correctly. So 3x times 2x squared is 6x to the third. 3x times 1x is 3x squared.
We're good.
We're good.
3x times negative 4 is negative 12x. Negative 1 times 2x squared is negative 2x squared. And I have a video on multiplying binomials. So if this is too fast for you, you can always check it out. Oh, so my producer says he'll link it down below. We'll see how that works and how that happens. I only have so many videos, so you could probably find it if you needed it.
For now.
All right, negative 1 times 1x is negative 1x. And negative 1 times negative 4 is plus 4. Now when I pull those out, I have 6x to the third. These two are alike, so I'm going to combine them. 3x squared minus 2x squared is 1x squared. These two are alike, so I'm going to combine them. Negative 12x minus 1x is negative 13x.
Look at that.
Yep. Be quiet.
Boys.
Mom's almost finished here.
And then the last one is plus 4. So does this match my initial dividend? It does, so I know I divided correctly. Now, I don't recommend that you do long division if you don't have to. All right, but the nice thing about long division is it's going to work in every case. Really, honestly, if you can, I would always recommend synthetic division. If you've learned tabular method or if you found someone online who shows the tabular method, My problem with the tabular method is I think once you get to problems bigger than this, it gets confusing. I like the tabular method pretty much only for very small division problems. There's also different methods where you can use factoring, and that's something that I was going to say if you're in class with me now I can show you. I can also do a video about it. But if you can't factor the dividend, then it's not going to do you any good, and you would have to rely on long division. So this is kind of like when nothing else will work, it will always work. And when you can't use a shortcut, long division is kind of your only method to use. All right, well, I'm sorry that my children were disruptive. Someone told me somewhere that having children would be lots of fun. I don't know. No, that's not true. They're very fun. So long division of polynomials with no remainder. I can put a video up for when you have a remainder. I can put a video up for when we do synthetic division. I can put any kind of video up that you want. So if you have a specific video request, just go ahead and comment, I don't know, somewhere on a video. I don't know if you can send me a specific message on YouTube. I don't know. I'm an old person and that's too much work for me. All right, but so this is Sittig. I'm out.
Subscribe.